We also have one proof. Actually, what is proof and proposition? Today we're gonna do three things. I'm gonna list here. Number one, we're gonna do proof by contradiction. Number two, we're gonna do proof by induction. And number three, today we're gonna do intro to logic. Okay, let's get started. Proof by contradiction. So in do now, I ask you to solve this problem 1, 1, and you have to find the hypothesis, which is 2 irrational number. Greek didn't like this irrational number. For Greek, the math was just a religion, because 2500 years ago there was no religion. At that time, they thought they treat math as a religion, and they thought that God doesn't like the irrational number. So the guy who came out with this irrational number, they killed him. They thought that by killing him, they can make God happy, so the irrational number wouldn't be existed. However, now we know that irrational number is as good as any number. So let's prove that irrational number actually exists. The square root of 2 is an irrational number. So we're gonna irrational number. We're gonna do proof by contradiction. Proof by contradiction. Step 1. We're gonna write the square root of 2 is a over b. Why would you write a over b? Because all the real number, whole number, natural number, integer, irrational, rational, and irrational. The whole number is 0, 1, 2, 3, and infinity. 1, 2, 3, all the way infinity. Integer 0, plus minus 1, plus minus 2, all the way infinity. Irrational number is, for example, 1 over 3, which is a over b. 0.333 is repeating, so instead of writing 0.333 forever, we just put a hat. Irrational number, for example, square root of 2 is an irrational number, which also can be written as a over b. Square root of 2 over 1. So now what are you going to do? You have to write a statement that a and b do not have any common integer except a and b in common integer except 1. So that makes it irreducible. Okay, how that would help us? That will help us to prove this by contradiction, that a and b do not have any common integer, any common factor except 1. That makes it irreducible. Now we're gonna square both sides. So 2 equal to a square over b square. Now we're gonna cross multiply it, or we're just gonna multiply both sides by b square. If we do that, 2b square is a square. Now let's take a look at a square. A square is 2 times b square. So 2 times anything is an even number, because if you plug in even odd number, that becomes 2. Any odd number you plug in It's an even number, so we can say that a square equal to 2b square is also an even number. So it's an even number. Now a, what is the product of a? A times a. So the product is also an even number. Okay, now how that would help us? It will help us because a equal to an even number. Why we choose to put 2k? We can put anything, but we choose to put 2k because k is an integer. So if you put any integer, it's going to be even number. That means if we plug it in, then 2b squared is 4k squared. So 2b squared equal to 4k squared, b squared is 2k squared. This is a problem. We said b squared, now b squared is an even number. B squared, which is b, is an even number, and 2k squared, which is a, is even number. In the beginning we said that a and b don't have any common factor. Now if both of them are even number, then they do have common factor. Not only one, but also two, because any even number, you can divide any even number by 2, so at least they have two common factors. That contradiction. So we're gonna write contradiction. So prove by contradiction. This is a rectangular sign. Mathematicians use the rectangular sign to claim that that's the end of the proof. Now